So let's start with the historical framework for the Arrhenius definition of an acid and a base. Now, to do this, we need to talk about what types of acids and bases Arrhenius was working with. Predominantly, these would be strong acids and strong bases, which is why his definition is the most limited, is that it only basically lets us work with things that act like strong acids and strong bases. But he made the observation that a strong acid reacts with a metal to form hydrogen gas and a type of salt. So that implies then that your acid here is going to produce H+ in solution. So this was a very good foundation to work with. So we've got our acid, in this case an aqueous acid, produces H+, in this case your conjugate base if it's reversible. But he was typically working with strong, so these are irreversible. So by the Arrhenius definition, our acid is something that dissociates to form H+ in solution, and this is how we increase the H+ concentration in solution with an acid. The point here is that the H+ is going to come from the acid, and this is going to be a rigorous definition that's going to contrast with the Bronsted definition when we start looking at bases. Now, we know that acids and bases react to neutralize each other, so how do we get rid of the H+? Well, the easiest thing we can do is if we add an OH-. So H+ plus OH- will give us water. So if we have some source of OH-, this would explain why the H+ would disappear. If we have H+ and we want to make water, we just need to add oxygen hydrogen to get us that. So by the Arrhenius definition, our base is something that contains an OH group. And this aqueous base is going to dissociate and give us H+, or our conjugate acid, and the OH-. So by the Arrhenius definition, a base is something that dissociates in water to produce an OH-. And this is going to be a very important definition to use here. The OH- here is going to come from our base. And if we add the two of these together, we have our acid plus our base. This explains how acid-base neutralization occurs. They come together, they form water, and our base and our acid form our salt. So this is the Arrhenius definition of acids and bases. In the Arrhenius model, acids form H+ in water by dissociating to give an H+. Bases remove the H+ by dissociating to give OH-, and that OH- has to come from the base itself. This explains why strong acids, when they react with metals, produce hydrogen gas because they're releasing H+. And this also explains why when you add an acid and a base, you get water and a salt. That H+ and the OH- combine to give you water. There is a major limitation with this definition, though, and this limitation is that something like ammonia, NH3, is also a base. NH3 does not contain an OH group, so how in the world does it act like a base? Well, to do that, we're going to have to move on to the Bronsted definition.